the Mississippi River is at historically low levels, which could impact the food supply and our wallets.
The Mississippi River is drying up. Water levels in some areas near historic lows.
On November 3rd, 2024, something happened on the Mississippi River that hydrologists once believed could never occur. In just 72 hours, water flow between Cairo, Illinois, and the Gulf of Mexico dropped by 47%. Not because of drought, not because of diversion, not because of climate extremes, but because the river itself began losing water internally. Barges carrying America's food supply sat stranded on sandbars that should not exist. Navigation channels collapsed. Intake pipes pulled air instead of water. And the river that built the United States began failing in real time. What made the event truly unprecedented was this. October rainfall across the basin was above average. More water was entering the system, yet less water was reaching the sea. At the Army Corps of Engineers' Vicksburg District Office, engineers stared at discharge data that violated the most basic laws of hydrology. The Mississippi wasn't drying up, it was draining itself underground. And the reason why forces us to confront a disturbing truth: we didn't break the river by neglecting it. We broke it by controlling it too well. Chapter 1. A River That Built a Nation. The Mississippi River is not just a channel of moving water, it is the circulatory system of North America. From the Ohio River to the Gulf of Mexico, the lower Mississippi drains 40% of the continental United States. Water from 31 states converges into a single artery, carrying sediment, nutrients, commerce, and life. For nearly 150 years, the U.S. Geological Survey has monitored this system with obsessive precision. Flow rates, sediment loads, chemical composition, temperature gradients, everything measured, everything modeled. And for over a century, the data told the same story. The Mississippi was predictable. Discharge at any point could be forecast weeks in advance, with over 90% accuracy. That predictability built an empire of logistics. Every year, more than 800 million tons of cargo move through the river. 60% of U.S. agricultural exports pass through this corridor. The river generates nearly $500 billion in annual economic activity and supports over 1.3 million jobs. But behind that stability lies the most ambitious river control project ever attempted by humans. A project designed with one goal: end flooding forever. Chapter 2. Engineering the Perfect Rivers. After the catastrophic Mississippi flood of 1927 killed over 500 people and displaced nearly 1 million, Congress made a decision that would reshape the continent. The Army Corps of Engineers was ordered to remake the river. Over the next 90 years, they built nearly 4,000 miles of levees, dozens of locks and dams, massive reservoirs, spillways, and control structures. The old river control complex alone used over 1 million cubic yards of concrete to prevent the Mississippi from changing course. And it worked. Floods became manageable. Cities expanded safely. Agriculture flourished on former floodplains. River transport became efficient and reliable. The Mississippi transformed from a wild system into controlled infrastructure. And that was the problem, because rivers are not pipes. They are living systems. By confining the Mississippi between levees, engineers didn't just stop flooding, they stopped migration. The river could no longer spread sideways, so it began cutting downward. Year after year, decade after decade. Slowly, invisibly, the river began eroding its own foundation. Chapter 3. When the models failed. In August 2024, Dr. Sarah Martinez noticed something wrong. As chief hydrologist for the Lower Mississippi River Forecast Center, her models predicted river behavior with extreme accuracy. But suddenly, the predictions stopped matching reality. At Vicksburg, flow rates looked normal. 7 days later, at Baton Rouge, nearly 140,000 cubic feet per second had vanished. At first, she suspected faulty sensors, but the data was correct. As she expanded the analysis downstream, the pattern became undeniable. Water was disappearing as it moved south, faster and faster with each mile. By October, the Mississippi was losing over 260,000 cubic feet per second along a 600-mile stretch. That's more water than the entire annual flow of the Colorado River. The National Water Center deployed an emergency team: hydrologists, geophysicists, structural engineers. What they found beneath the riverbed shocked everyone. Chapter 4. The riverbed turned sponge. Sediment cores taken from the Mississippi revealed something unprecedented. The riverbed had lost its structure. Natural riverbeds form layers, sands, silts, clays, that resist downward water movement. But these samples showed complete homogenization. 80 feet of sediment churned into a highly permeable mass. The riverbed had become a sponge. Why? Decades of sediment starvation. Upstream dams trapped the sand that once replenished the lower river. Reservoirs captured another 60%. With no replacement material arriving, the Mississippi compensated by eroding downward. At the same time, groundwater pumping across the Mississippi River Valley dropped aquifer levels by nearly 30 feet. That created a pressure imbalance. Water sitting above a depleted aquifer and a porous riverbed began draining downward at unprecedented rates, a process engineers call induced infiltration. Individually, each factor was manageable. Together, they transformed the river into a groundwater recharge system. We engineered the Mississippi to drain itself underground. Chapter 5. Collapse moves faster than ecology. The ecosystem collapsed first. Fish species dependent on specific flow velocities failed to reproduce. Mussel beds suffered mass die-offs. Wetlands dried, bird migration patterns fractured along the Mississippi flyway. But the economic collapse arrived violently. Navigation depth dropped below 9 feet. Barges reduced loads or ran aground. Cargo volumes fell by more than 50%. Soybean shipping costs nearly doubled. Farmers absorbed the losses. Bankruptcies followed. Ports shut down. Jobs vanished. Cities lost tax bases overnight. Then came drinking water. Saltwater pushed upriver toward New Orleans. Emergency freshwater barges were deployed. Temporary barriers were built at enormous cost. Memphis faced contamination as the river drained directly into groundwater wells. This wasn't a single disaster. It was a slow, grinding strangulation of an economy built on assumptions that no longer applied. Chapter 6. When fixing the river made it worse. The Army Corps of Engineers moved quickly, confident that engineering could reverse what engineering had caused. Reservoirs upstream released additional water. Groundwater pumping was restricted. Emergency dredging began. Recharge basins were built to capture water leaking underground and pump it back into the river. On paper, the plan worked. In reality, the river responded in ways no model predicted. The added water increased pressure on the porous riverbed, accelerating infiltration instead of restoring flow. More water did not move downstream. It vanished faster. Groundwater restrictions forced farmers to compensate by pulling directly from the river, increasing surface withdrawals. Each fix shifted the burden downstream. The recharge basins created a final paradox. Water was pumped back into the channel, flowed briefly, then disappeared underground again within miles. By spring 2025, officials quietly stopped talking about recovery. Internal reports replaced restoration timelines with a new phrase: managed decline, a river beyond control. The Mississippi River is no longer behaving like the river we knew. Not because nature failed, because engineering succeeded too completely. We eliminated floodplains, blocked sediment, drained aquifers, confined flow. And in doing so, we rewrote the physics of the continent's largest river. Some systems don't break dramatically, they transform quietly. Monitoring stations still transmit data, models still run, committees still meet. But beneath the riverbed, hundreds of billions of gallons vanish every day. following gradients we created, through sediments we destabilized, into aquifers we depleted. The Mississippi isn't dying. It's becoming something else. And the question we now face isn't how to restore the past, but whether we can live with the equilibrium we accidentally engineered. If you want more deep investigations like this, hit like, subscribe, and turn on notifications so you don't miss what happens next.